Alright, we're continuing here and we're going to talk about square roots. Now, we have a much more complicated version of this coming later, but for now the idea is that just like I believe we saw absolute values already, somebody said, hey, do you know sometimes the numbers factors are the same thing? Like 9 is made up of 3 times 3. Well, they wanted to say when that happens, well, what's that common factor? So 16 can be thought of as 4 times 4. And so they said, hey, I keep seeing a pattern. Let's give this thing a name. And they called it a square root. So this is asking in English, hey, what's that number that is the identical factor of 9? Well, it's 3. What's that number that's the identical factor of 16? Well, it's 4. So this is called a radical sign. I never use the term radicand, but that's inside of there. So we're looking for what is the number. So the factors of 25 are 5 times 5. So you could think of it like this. This is what's in there. So 25 is made up of 2 of the same number. So we can bring the 5 outside of the house. Now the way I'll teach this later, and I would just go ahead and show it to you here, is a square root means 2 of the same thing can come on out. So if I've got 25, it's made up of 5 times 5. So inside the house, I turned it into 5 times 5. It takes a pair to bring 1 outside of the house, so I can bring out a 5. So 121 is made up of this. Okay, well, it takes 2 of them, it takes a pair to bring 1 of them out. Now, this is going to be an essential skill later for some much more complicated algebraic stuff. But if you know your square roots, you don't have to do this. But it's going to be something you will need later. So, square root of this is 6. 169, I believe that's 13, isn't it? Let me check. Yeah, it is. So, again, the way I can show this, like when it's going to be something more difficult, maybe they'll come. But so 169 is made up of this. A pair of them lets you bring out 1. Okay, square root of this is 4. Yeah, here's a good one to show you the trick on. So this is why factors are so important all the time. Okay, so suppose you didn't know. I can break down 196 into its pieces, its prime factorization. So watch this little trick. So it takes a pair to bring something out. So I can bring out a 2 and I can bring out a 7. So when you've brought them out, put them back together. I brought out a single 2 and a single 7. That's 14. Okay, so we're going to get some variations of this here. Now, I've got a negative out front, but the square root part is going to be the same. So I just take the 3, the square root of 9 is 3, got to put a negative in front. Square root of 144 is 12, put a negative in front. So same thing here, square root of 4 is 2, so it's a negative 2. 225, is that 15, I think? Yeah, it is. But so let me do this one again if you didn't know. So if you weren't sure, I'm going to do my tree. So it ends in 5, so I'm dividing it by a 5. Okay, so I broke it down, and it's made up of 3 times 3 times 5 times 5. Okay, so a pair of 3's lets me bring out a 3. A pair of 5's let me bring out a 5. Now I'm going to put them back together. I got a 3 outside and a 5 outside. That's 15. Now there was a negative out there already. Negative 15. Okay, this is square root of 81 is 9. It's negative. Square root of 100 is 10. Negative. All right, now we're going to start discussing some details about the different kinds of numbers. When I was a student, I always looked at this and I didn't think it was all that important. But it turns out that the better you understand this, it's very helpful, especially in college algebra and beyond. So a rational number is any one that we can express in some form as a fraction. There's some way to turn this into a fraction. So what are we doing here? I don't understand what this is doing. Okay, I'm not sure what they're doing here, but obviously both of these could be written as a fraction. You can always put negative 27. You can always put a whole number over 1, so now it's a fraction. And that's the same number, so we're good. Now we saw we could do 7. We saw how to do 0.31. Do you remember we could do 31 over the tenths hundredths place? So both of these numbers, now you could turn this into an improper fraction if you wanted. So 731 over 100. But the point is just this. These can both be expressed as fractions. Now, this is not a question I have ever asked anybody, but we'll just do this quickly. Yes, that could be a fraction. So, how about in 357 we could do that. So, and we could have made it an improper fraction. So they both can be expressed, so they're rational numbers. Same thing. 41 over 100 for the second decimal place. Okay, now irrational numbers are those that cannot. So if you tried to turn them into a decimal, they would never repeat. And so that prevents us from setting them up as a fraction. So if we see here, this repeats, so that's rational. This ends. So if it ends, it's also rational. But if it goes on forever and it never seems to find a pattern, now it looks like it's going to be 5, but then it takes a turn, so it is not. So this is irrational because it doesn't stop or repeat. So if we're going through here, that ends, so it's rational. That one repeats with the 6, remember what the line means? So that's also rational. This one never repeats, it just keeps changing, so that is an irrational number. So this one ends, so it's rational. Or I'm sorry, this one repeats, so it's rational. This one ends, and this one just keeps going on indefinitely. Okay, now when it comes to roots, here's the deal. It is square roots, if they are not a perfect square, like if it does not turn into a number, then it's irrational. And so what I mean is this. We know the square root of 36 is 6, so that's a rational number. But 44 doesn't have a natural or a perfect square. So square roots are actually the most common type of irrational number. They would just go on forever and ever. So a perfect square is rational, but if it's a square root and it doesn't have a perfect square, something you can take out, that like everything comes out, then it's irrational. So this one is 9, so that's rational, but that's irrational because you can't bring the number out. So this one is 11, so that's rational. That's going to be irrational. Okay, now when you get to college algebra, there is something called imaginary numbers, but and it has to do with a negative underneath the square root sign. But for now, any number, rational or irrational, is just called a real number. All of those things are still real. They don't involve the imaginary stuff that we see in higher math. So here's a little chart that we've got here. We started with the counting numbers. That was 1 going up, like you're counting your fingers and toes. Whole numbers added 0. Now integers are whole numbers, but we also had their opposites. So it's negative 5, negative 4, negative 3, but we didn't have any fractions. Now we have rational numbers that can be expressed as that fraction. Somehow you could turn it into a fraction. And then we have these irrational numbers where you can't. So like square roots, another example of that is pi. That's another one. There's also another number called e. That these are irrational numbers. They just keep going on forever. So roots that aren't perfect, like square root of 17, those are irrational numbers. All right, so now they're asking us whether something is a real number or not. So in this course, the only time it wouldn't be a real number is if we had a negative underneath the root. So we can't do this. There are no two numbers. So you think, well, why not? 169's got a square root of 13. Yeah, but what this says is two of the same number turn into negative 169. Well, there aren't two. Negative 13 and negative 13 become a positive again. So there's no way to do this. So this is not a real number. Now this is, the negative's on the outside. That's fine. This is 8 and a negative 8. That's a real number. Okay, so we're doing this here, and we've got, this has a square root. It's 9, so this turns into negative 9. That's certainly a real number. This has a negative underneath the root. That is not a real number. That is that is not a real number. So that's a real number. This is not, because of the negative under the root. Okay, now they're going to ask us to go through and see if we can tell all the different types of numbers that we have. And again, I used to see this question and it didn't interest me very much. I didn't think it was all that valuable. But it turns out as you go forward, it's more valuable than you might imagine. So all the whole numbers, well, we learned whole numbers are from 0 on up. So 8 is the only one of the whole numbers. So if we're looking at this list here, what else we got? Integers. Integers are the whole numbers and their opposites. So these two would be integers. Okay, rational numbers are anything that can be expressed as a fraction. Well, this guy can, this guy. All of these guys can. Now, irrational numbers, we have any roots. So here's our irrational number. We've got a root that isn't a perfect square. Okay? Yeah, I should have figured it. This actually is an integer. So if you take the square root of 64, you get 8, and so it's negative 8. So this simplifies down to be negative 8. So that would have been an integer. Okay, so did I ask? Okay, so they are all real numbers. Every one of these, we don't have any that aren't real numbers. Okay, so let's go through whole numbers first. So the only whole number is the number 4, because that was 1 on up. Now we go to integers. Well, this guy, so negative 3, 4, and then this guy, because it's really 7, we're going to say he's an integer. Okay, rational numbers are any that can be expressed as a fraction. So that can be. This can be because he repeats. This already is 1. 4 can. And that can too because he's really just 7. Now, irrational numbers are those that repeat or that don't repeat. So this guy is an irrational number. Now this is really 7, so he's fine. Now real numbers. They're all real numbers as long as we don't have a negative under a root, so all of them are real. Okay, pause this if you want to try on your own. Go through this here. Whole numbers, it's only 6. Integers are negative 1 and 6. And then this turns out to be negative 5, so a little tricky there. Okay, rational numbers are any that can be done as a fraction. Well, that's negative 5, so it could be. That is a fraction. That can be made a fraction. That can be made a fraction. This is 11, so he could be a fraction. This is the only one that would not be able to be turned into a fraction. So if he can't be turned into a fraction, he's an irrational number. Yeah, all the rest of the square roots can be done, so that's the only irrational number. And then they're all real numbers as long as you don't have a negative under the square root, and none of those do. So they're all real numbers. Okay, now that may not seem all that interesting, but if you understand that really well about the classifications of the numbers, it'll really help you as you move into college algebra.